What's up, 8th grade? Mr. Agnos here. For topic 5-6, we're going to continue to study lines and linear equations. Specifically, we're going to be given a graph and try and create the equation that would generate that line. So let's take a look at some examples. All right, so here we have 3 lines, and they want us to write an equation in slope-intercept form for each line. So the first thing we need to talk about is, well, what is slope-intercept form? And I already showed this to you guys over the last week and a half, but the slope-intercept form of a linear equation is y equals mx plus b. And we've been talking about this a lot. And in order to write an equation in this form, you need to know 2 things. You need to know the slope, which is the variable m, and you need to know the y-intercept. In other words, if you can figure out these 2 things about a line, then you can write the equation for that line. Now this is called, a lot of times you'll just hear it referred to as y equals mx plus b form. It's called slope-intercept form because it uses the slope and the y-intercept. All right, so let's take a look at graph A. I need to figure out 2 things about this graph. I need to figure out what is the slope, okay, what is that, and I need to figure out what is the y-intercept. And if I know those 2 things, then I can just plug them in for m and b and I'll have my equation. All right, I always start with the y-intercept because the y-intercept is easy. Just look, where does the blue line cross the y-axis? For graph A, it crosses right here at 1, so b is equal to 1. All right, finding the slope is a little harder in this section because they don't give you 2 points. In the previous topics, they've actually had 2 dots there. So you actually need to find some points on your own. So it's really important that you look, where does my blue line intersect with the crosshairs of the graph, I guess is how I'll put it. So what I do is I kind of start at my first point here, and I'm just going to move up my line until I get to a point where the blue line intersects the crosshairs right here. That way I can accurately count squares to measure, hey, what is my rise and what is my run? All right, so to get from my first point to my starting point to my ending point right there, I have to go up 1, 2, 3. So I have a rise of 3. And I have to go to the right 1 unit. So there's a 1. So this is 3 over 1. Now, when you're writing the equation, we're going to want to simplify this, right? When we're graphing, we would actually leave it like this because it tells us what to do. 3 over 1, that simplifies to 3. Okay, so now I know that the slope is 3 and the y-intercept is 1, so just plug them in. Plug in 3 for m and 1 for b, and you have your equation. So the equation that generates graph A here is, oh boy, is y is equal to 3x plus 1. I just plugged in 3 for m and 1 for b. So this equation right here will create this line. All right, let's look at graph B. The first thing I notice about graph B is that it's going, excuse me, is that it's going down from left to right. And what that tells me is I'm going to have a negative slope. So already I'm thinking to myself, all right, make sure that your final answer has a negative slope. All right, let's look for the y-intercept. It is right here at 4. Easy peasy. Now, I'm going to start moving down my line until I get to a point where it intersects at the crosshairs. There's a point. And those are kind of close together. You could even keep going. There's another point right there. It doesn't matter which 2 of these points you use. You could use any 2 you like. I'll use these first 2 here. So the first thing I'm going to do is I have to go down 2 units. Right? And because I'm going down, 1, 2, it's negative 2. And this is what's going to make my slope negative. So my rise is negative 2. The run, I go to the right 1 unit, So the slope is negative 2 over 1. We have to simplify that. Anything over 1 is just itself. All right, so now I go to write this equation. Don't let the negative mess you up. We just plug in negative 2 for M and 4 for B. So the equation for line, for graph B here is y is equal to negative 2x plus 4. So this equation right here will generate a line that looks like this. All right, last one. Notice how I approach every single problem the same, right? I always start by writing m equals b equals. This reminds me of the two things I need to find. I look for the y-intercept first because it's easy. You just got to look. There it is. That is at negative 3. Don't forget it's negative, right? We're below the x-axis here. Negative 2, negative 3, negative 4. So that's negative 3. And then I'm going to start here, and I'm going to move up my line, and I cross through the crosshairs right there. I also cross through the crosshairs right here. So you could use any two of those points and get the correct slope. So the first thing I have to do is go up 1 unit. So my rise is 1, and my run, I start here, and I go to the right 2 units. 1, 2. So my run is 2. This is a simplified fraction. It is okay. I mean, most of the time we've been seeing integers or whole numbers. This time we got a simplified fraction. That's fine. So the equation for, I'm trying to decide what color I want to use here. The equation for this line is y is equal to, I plug 1/2 in for m. So that's 1/2 x. All right, it's negative. This is negative. So I can actually write this two different ways. I can write it as plus a negative 3. That's one way I can write it. Or you can simplify this, right? Adding a negative is the same as subtracting. So y is equal to 1/2 x minus 3. These are mathematically identical. They mean the same thing. I believe the homework assignment will accept either. If not, then you would have to do the simplified version. But if I recall from past years, I think the homework assignments will accept either. So you can either add the negative or subtract. Just make sure that you have it negative. Okay, let's take a look at a little more contextualized problem. Contextualized problem means it has a story to it. I'm still getting these weird error messages. They go away after I reload the page. Here we go. All right, I'm going to zoom in a little bit. Here we have a graph that says the line models the relationship between a temperature in degrees Celsius and degrees Fahrenheit. All right, and then they ask us a bunch of questions here. Let's just go through the questions one by one. The first question that they ask us is, what is the y-intercept of the line? All right, notice they've only given us the first quadrant here. That's fine. They've labeled my y-axis. It's right here. And here's my x-axis right here. So my y-intercept is simply this point right here, right, where the line crosses the y-axis. Now, you can't really tell from the scale what this point is, right? It's somewhere between 25 and 50. But luckily, they tell us. They say, hey, this is the point 0, 32. So for this line, the y-intercept is 32. And think about that. We're measuring degrees Celsius on the x-axis, degrees Fahrenheit on the y-axis. Well, remember, 0 degrees Celsius, the temperature that water freezes, is 32 degrees Fahrenheit. So this is freezing temperature in Fahrenheit, and this is freezing temperature in Celsius. All right, so we know that the y-intercept over here is 32. All right, what is the slope of the line? Okay, so they give me 2 points right here. I gotta be a little careful here. I can't count squares. I can't use the scale here. But I still need to figure out, well, how much did I go up to get from here to here? And how much did I go to the right to get from this point to this point? Well, luckily they gave me the coordinates of the 2 points. So if I need to know the length of this blue arrow, I just look at the y coordinates. We're starting at a height of 32, and we're ending at a height of 104. So I went from 32 to 104. So if I subtract those two, it'll tell me the length of this arrow here. So 104 minus 30 would be 74, minus 2 more would be 72. So the length of this blue arrow is 72. Okay, and again, I use the coordinates. Basically, remember the slope formula? You know, y sub 2 minus y sub 1? That's what I just did. I did 104 minus 32. That gets me a 72 for the rise. And then the run is even going to be easier because we're starting at 0, right? I need that to be red. We're starting at 0 and we're ending at 40. So that means my red arrow is 40. So the slope of this line is 72 over 40. We need to simplify this, right? It's not going to accept this. It's going to say your answer is correct, but it's not simple. All right. When you have a messy fraction like this and you don't know the greatest common factor, which would simplify this in one step, just go ahead and say, well, they're both even, so I'm going to divide them both by 2. Let's see where that gets me. If I divide these both by 2, I'm going to get 36 over 20. Okay, I'm getting simpler. These both have a common factor of 4. So I can keep going here. So if I divide this by 4 and divide this by 4, I get 9 over 5. 5 is a prime number, so this can't be simplified any further. All right, so m is 9 over 5, b is 32. So my equation that models the relationship between degrees Fahrenheit and degrees Celsius, remember we write all equations in y equals mx plus b form. Well, I'm just going to take I'm going to take 9/5, plug it in right here. I'm going to take b, plug it in right here. So my equation is y is equal to 9/5 x plus 32. And what this equation will do is take the temperature in degrees Celsius. So x is measuring degrees Celsius. So if you know that the degrees Celsius, you can plug it into this equation and then solve it, and it will tell you the corresponding degrees Fahrenheit. Okay, so some new stuff in this unit, or maybe just going a little further with what we were learning the last couple of weeks. Make sure you ask lots of questions in class, and I will see you guys soon.